Okay, so in this video we will be seeing how to blur any image with the help of OpenCV. Okay, so for blurring the image there is one function in OpenCV which is known as Gaussian blur function. So this function is used to basically blur any image. So this function has 4 parameters in it, which I will be telling you, explaining you one by one, don't worry. Okay, so if you want to basically blur any image, then you will be using this cv2 dot Gaussian blur function. Okay, you will be using this cv2 dot Gaussian blur function. So first of all, you will be writing the cv2, the name by which you have imported OpenCV. Then you have to write dot, then name of the function which is Gaussian blur, and then you have to pass 4 parameters inside this. What are the 4 parameters? The first is the image, which is basically the name of the image or the source of the image. I hope the image is in your same folder in which you are doing the project. Then what you need to do is you need to write two things. First is the x coordinate of the kernel, and then another is the y coordinate of the kernel. It is always advised to write the to choose the value of the x and y as odd, like 3 3, okay, or 5 5, or something like that, never even. Okay, next there is one more value, there is one more parameter, which is sigma. Okay, so this sigma basically controls the level of blurriness. Okay, this sigma basically controls the level of blurriness. If you set sigma is equal to 0, that does not mean that the image will not be blurred. It will be blurred, but that the level of blurriness will be chosen by cv2 library itself. Okay, that will be automatically chosen. There will be a random number which will be chosen by cv2 in order to blur the image. So if you set sigma to 0, that means the cv2 library will automatically choose a value for blurring the particular image. Okay, so these are the 4 parameters. What is image, kernel size x, kernel size y, and then sigma. So this kernel size x and y should be in one tuple, right? So it will be in one tuple, there will be 2 values. Okay, now let's see. So first of all, what I will be doing is I will be importing the cv2 library, and then I will be using the cv2.imRead function in order to read an image and store it in a variable called image. Okay, then I will be using the cv2.Gaussian blur function. Oh, wait, there is one error in this. What is the error? The error is basically the G will be in capital letter, it will be in caps. Okay, the Gaussian blur function I will be using in order to blur the image, right? And inside that I will be using 4 parameters. First is the image, right? First will be the image. Why I have written image over here? Because this entire image is stored in this variable which is image, and then basically I am using this variable because this variable has the actual image, right? That's why I am using this variable, because it is stored directly. If I don't do this thing, then I have to directly write the name of the photo, which is nature.jpg over here, but I have stored it inside the variable image. That's why I'm just writing image over here. Then I need to write the x coordinate of the kernel and then the y coordinate of the kernel. Obviously there should be a comma in between, and then I need to write the level of sigma. Let's say if I write the value of sigma as 3. Okay, I will write the value of sigma as 3. Now what I will be doing, cv2.imshow, I will be using the imshow function in order to display the image, which is now here what I am writing, actual image. So if you want to show the image, you have to use the imshow function, and there will be two things. First will be the name of the image including the extension, and then you need to write the name of the variable in which that actual image is stored. So I am doing that thing, actual.jpg, name of the image and the variable in which the image is stored, and then I need to also display the blurred image. For that I will also be using the imshow function. So cv2.imshow, then I have to write the name of the blurred image, which is blurred.jpg, and then I also need to write the name of the variable in which the blurred image is stored, that is blur only. So I am writing blur over here. Now what I need to do, I need to write this cv2.waitkey 0. So what does this function mean? This function means that whenever the user will press any key, let's say when I will be displaying these two images, there will be two windows open, right? One window will be for the actual image and one window will be for the blur image. Okay, now when I will be writing cv2.waitkey 0, what it will be doing, it will be basically whenever I press any key in the keyboard, after 0 milliseconds, both the windows will be closed with the help of destroy all windows function. This destroy all windows function will be closing both the windows. Okay, after how many milliseconds? 0 milliseconds. If I write something like this, cv2.waitkey 5, that means what? These two windows will be closed by the destroy all windows function after how many milliseconds? 5 milliseconds. So you need to understand this thing, okay? But generally nobody does this. I just told you because you need to understand what is the function of this value. So I'm just writing cv2.wait key 0. That means after 0 millisecond both the windows will be closed by the destroy all windows function, okay? Whenever I press a key, if I don't press any key, then nothing will be closed, okay? Now if I see the image, now let's see the output, what it is showing, okay? So let's see the output. So you can see there are two images. The first image is the original image and this one is the blurred image. As you can see that the original image is a bit clear, but the blurred image is a bit blurred, right? Why it is blurred? Because I have set the value of blur to 3, right? If I have set the value of sigma to 3, right? Sigma basically controls the level of blur. I have set it to 3. If I just set the value of sigma to 10, let's say, then the image will be more blurred, obviously. So this depends on the value of sigma only, how much blurred the image will be. So this was the first blur function, which was the Gaussian blur. So you can use that function in order to blur any image. Now you might be thinking how this blur thing is done. So basically how the blur is done, let's say I want to like blur this portion, right? So as you can see that this portion is now this portion is a sort of blurred, right? This portion is blurred. So how did I blur this portion? So what I did was that I just took all the pixels that are present in this area, okay? So every pixel has a RGB value, right? So what I did, I took the R value of all the pixels, and then what I did, I did the average. That means to R value of all the pixels divided by total number of pixels. Then then the value that I got is the value of R, right? Then I need a value of G. So how will I get the value of G? I will select the G value that are present in all the pixels, and I will then divide it by the number of pixels. So I will get the average G value, which I will be putting over here. And for the B1 also, I will select all the pixels, blue value from all the pixels. I will be summing them up, and I will be basically doing the average by total number of pixels. So the value which I will be getting, that will be for the blue value. So this will be the color of one pixel, and I will use this pixel with this intensity of red, green and blue lights in order to color all the pixels. I will use, let's say I got this 128, 130 and 140. So I will basically color all the pixels with this same color code, right? 128, 130, 140, then 128, 130, 140, 128, 130, 140. That's how I will just color all the pixels with these RGB shades, okay? Every pixel will have the same value in that area which I want to blur. So that's how I blur the image. So this is basically the math behind blurring. So now we will be seeing the second type of blur, which is median blur. So why is median blur used? Median blur is used for image cleaning purposes, okay? For example, let's say there is an image of a person's face, okay? Let's say this is the image of a person's face, and let's say the person has many pimples on his face, and now I want to transform his image into such image where his face has absolutely no pimples. That means what I have to do, I need to just basically blur out the pimple areas, or I need to do something like this, that the image shows that there is absolutely no pimples. So basically what I need to do, I need to basically blur the pimples, right? I need to make the image a little blurry so that the exact details, the minute details do not get visible. So for that I will be using the median blur. So how this works, basically it takes the middle value of the neighbor's pixels, the pixels where the neighbor pixels beside the pimples, right? Let's say these are the pimples and these are the neighbor pixels which are beside the pimples. So it will take the middle value of the pixels which are beside the middle values of the pixel which are beside those areas which you need to blur. So that it will take the middle value and it will basically apply those middle value in those parts where you want to blur. That's how it will blur, right? So how will this so let's look at the syntax of the median blur. So for that you have to write cv2, then you need to write the median blur function. You need to remember that m is in small, b is in capital, right? And inside that here will be two parameters, right? Here will be two parameters. What are the two parameters? The first is the image and the second is the kernel size. Okay, and you should always remember that the kernel size should be odd, and if you increase the value of kernel size, then the level of blurriness will also increase. Okay, you need to remember that thing in mind. Now let's write the code. So first of all, I need to import the OpenCV library. Now what I need to do is basically I need to first of all read the actual image and store it in a variable called image actual.jpg. Okay, actual.jpg, you can just write the name, let's say face.jpg. okay, let's say the image which I want to blur is basically face.jpg. okay, so basically this image is read by using the imread function, and it is stored in the variable image. Next, what I am doing, basically I am creating another variable called blur, which will store the blurred image, and for that I will be using the median blur function. Inside that I will be pass the actual image, the variable which is holding the actual image, and I will set the value of kernel size to 11. So if I set the value of kernel size to 11, it will become very highly blur. If I increase the value of kernel size, it will become more blur. So I will set the value of kernel size to 11. Then I will be basically showing you the actual image using the cv2.imshow function, and then I will also again use the cv2.imshow function to show the blurred image. Okay, and then finally I will be using cv2.waitkey 0. That means whenever I will press a key on the keyboard, within 0 millisecond all the windows will be closed. So there will be two windows. This is the blur, and there will be another window whose name is actual. So these two windows will be closed. At that time, whenever I will press any key on the keyboard, this function basically will kill these two windows. Okay, so that's how the median blur is working. Okay, now what we will be understanding about the filter 2D function. So what is the filter 2D function? It is a function in OpenCV that is used to basically sharpen a blurred image. If the image is blurred, okay, and you want to make the image more sharp, that means you want to make the features or the contents in the image more visible, then you need to use the filter 2D function, which is used to basically sharpen the blurred image. Now what is the syntax? It is basically cv2.filter2d, and inside this function we will have three parameters. First is the image source, second one is the d depth, and third one is the sharp kernel. This is basically a matrix which will basically hold a particular type of kernel matrix, in which I will be telling you what type of kernel matrix to give for which purpose. Okay, you just need to know that thing only. And numpy is needed, okay, because we will be basically creating this matrix. Okay, with the help of numpy np.array, we will be using that function in order to create this matrix. For that, numpy is also needed. Okay, so this matrix, this is a special type of matrix which is called the sharp kernel matrix. So this is basically used when you want to sharpen the middle part of the image. When you want, if there is an image, this is an image, let's assume this is the middle part, and if you want to sharpen the middle part of the image, then you have to use this matrix in order to sharpen the middle part. So how will you understand? See, here you can see the corners are all 0. That means if all the corners are 0, it is trying to say that don't try to sharp the corners, keep the corners blurred or as it is, don't do anything with the corners. Now you can see that the value of the center is 5. That means what? The value of center is 5 means make the center of the image the most what you can say, sharpened. The make the center part of the image the most sharpened. Okay, for that we have write 5. Middle part of the image will be the sharpest, because middle part has the highest value in this matrix, right? Now, so you need to create this matrix, and you need to pass this matrix inside this function, as you can see. So there are three parameters: image, d depth, and sharp kernel. Now basically we need to code this. So basically we are importing two libraries, right? The first library is the cv2 library, the OpenCV library, and then is the numpy library. Now what we are doing is that we are creating the sharpen kernel matrix. So the name of the matrix is sharpen kernel, and we are using the np.array function, and inside this we are creating the matrix. The first row will have 0 minus 1 0, the second row will have minus 1 5 minus 1, the third row will have 0 minus 1 0. That's how we have created the sharpen matrix. Now what we are doing, using the np.array function, obviously. Now what we are doing, now we are creating the new image by applying the filter 2D function. So new image, we are creating a variable called new image, and inside that variable we will be storing the sharpened image. So we are writing cv2.filter2d function, and inside this we are passing three parameters. First is the image source, Okay, so the entire image is stored in this variable named image, so we have passed this variable over here. Next, the d depth of the image, which is -1, you don't need to know about that. Okay, and then we need to write this then we need to pass the kernel matrix inside this function. So the kernel matrix is stored in the variable sharpen kernel, so it is passed in the function. Now what we are doing, we are basically showing the actual image, the blurred image, using the cv2.imshow function. See, this is the blurred image. Now we are again using the cv2.imshow function in order to show the sharpened image. So as you can see, the sharpened image is stored in this variable new image, which is getting shown. So how will it be shown? So basically this will be the new image variable, the content of the new image variable, and it will be named as what? Sharpened dot jpg, if I am not wrong. This will be the name, obviously. Now cv2 dot wait key, so there will be two images stored, there are two images opened, this one and this one. So this will be the actual dot jpg, and this one will be the sharpen dot jpg. Now cv2 dot wait key will wait for 0 milliseconds after we have pressed a key, and when we have pressed a key within 0 millisecond, these two windows will be closed using the destroy all windows function. So basically you can do this in order to sharpen the image. Just you need to remember the kernel matrix, what is the kernel matrix and what are the parameters which are used. So three parameters: the source of the image, the depth of the image, and the kernel matrix, right? So this is what it is. Okay, so here we will be studying about the canny edge detection. Okay, so basically canny edge detection is a type of algorithm which is used to detect borders of any object. Okay, so I have written the uses. It is basically used to detect the borders of any object. Okay, next what it is used, it is basically used in order to detect the borders of a face during face detection. Like let's say this is a face. Okay, I know I am very bad at drawing. If you need to detect the border of this face using, for face detection, you need to do this canny edge detection. Okay, next, for example, if you have a image which has a circle in it and you need to uh, check, detect the outline or the border of a circle, then you need to use the canny edge detection. Basically, if you need to see the borders of any image or an object inside an image for border purposes, we need to extract the borders, then you need to use the canny edge detection algorithm. Now what is the syntax? The syntax is nothing but cv2.canny, and inside that there will be like three values or four values that is completely dependent upon you. So basically there will be an image, there will be a threshold value, and there will be another threshold value or max value, whatever it is. Okay, so here threshold is a particular value which I will be explaining you later. Okay, threshold 2 is not that much required. So basically what it is doing, first of all we are importing the cv. So keep one thing in mind before applying canny, before applying this canny algorithm on any image. First of all you need to convert that image into grayscale, then only it will work, else it will not work. So this is the first and foremost thing: convert the image into grayscale, then apply the canny algorithm. Okay, so you need to know this thing. So basically we are doing that thing only. First of all we have imported the cv2. Now we are using the cv2.imread function in order to read the image whose name is flower.jpg, but we are reading the grayscale version of flower.jpg. For that, what I am doing, I am using a property which is cv2.imread underscore grayscale. This property is used to convert a color image to a grayscale image at the time of reading only. Okay, at the time of reading, it is not converting it completely, it is just converting it at the time of reading. Okay, but if you save the image, it will be a color image only. So you need to know that thing. Okay, so basically this cv2.imread underscore grayscale is converting the colored image into grayscale. Now basically you are using the cv2.canny image 5150. Now what does this mean? See, image is, I know image is the variable which is storing the actual image or the grayscale image. Now what is 50? 50 is the threshold value. See one thing, obviously in grayscale the shades are from 0 to 255, right? 255 means pure white, right? And 0 means what? Pure black. And here the value is 50. So this is the threshold value. If so, what it will do, the algorithm will check every pixel, it will check the color of every pixel. If the value of any pixel, let's say this one is greater than 50, let's say it is 60, so it will convert it into pure white, 255. Let's say the value of this pixel is like 30, so it will basically convert it into 0, that is pure black. So it will be either 0 or 1, that means it will be a binary black and white image. So basically it will convert any image into a black and white image, so you need to understand that thing. Next, let's say it will check this pixel, the value of this pixel is 90, so obviously it is greater than threshold, so it will convert into 255, so it will be converted into bright white. So basically it will be just uh, creating a black and white image of that particular image. So this is what it is going to be done. Okay, so you need to understand that thing. So ages equals to cv2.canny image 5150. Okay, this is used to basically detect the what, detect the borders of the image. Now we are using the cv2.imshow function in order to show the new image. Obviously this will be in black and white. Next we are using the wait key function, so that we can, if we press any key, then all the windows will be destroyed. So this is what it is. Now we will be talking about the bitwise AND operation within images, the bitwise OR operation within images, and the bitwise NOT operation within images. So basically what is bitwise AND operator doing? The bitwise AND operator is basically used to take the common part of two shapes, the common area of two shapes, or the intersection area of two shapes. So let's say this is the image has a square and this image has a circle. So if I perform the bitwise AND operation between them, so I will get this area. So this area has the common part of the square and the circle, the part which is coinciding, okay, the part of the circle which is coinciding with the square, that part is taken. Okay, I hope I am able to make you understand. So what is the bitwise OR operator doing? The bitwise OR operator is basically taking both these shapes. That means they are basically merging these two shapes. Okay, so we are basically doing that thing only, as you can see. Now there is one more operator which is basically bitwise NOT. So it is used for black and white images only. Now it cannot be used for any color image or grayscale image. So the bitwise NOT operator is basically used to change the color of an image. So let's say if it is a black and white image, so this part is black and this part is white. It will make into a white and black image. So this part is white, this part is black. So basically it will just flip the colors. So this is it. Now let's look at the code.